ladies. So I'm gonna do a little intro on cup coding because just reading it is kind of weird. So here's an example. You're gonna use your plethora of red cups because you're like, oh, why are all these cups here? Ha, this is why. Also, I just have these little cups because that's what's here. So it's important to explicitly tell the kids that each line of their code equals 1 cup. So for example, I know looking at this code, I'm going to use 3 cups. So I should only have a stack of 3 cups. When I'm doing this, I'm starting on the left and moving to the right, just like we would when we're reading. In the video, I think it does it backwards. I don't know how to change it, so you're just going to have to deal with it, okay? Yeah, there's that. Yeah, so you need to explain to kids that each arrow in the code to the right is a half a cup length. So this would be a whole cup length. Half a cup length would be here. And the reason for this is if we did all of the arrows full lengths, we couldn't stack. So make sure that they completely understand that 2 half movements equal 1. It's a good way to work with fractions because they should be working on fractions in 4th grade anyway. It's a good reminder, hey, 2 halves, 1, 2 equals 1 whole. So just make sure, because you will have kids that they're wanting to stack, but then they literally put the exact same code. They'll say up, over, down, and then the next one they'll say up, over, down. They've stacked it, but not in the way that they're thinking. They're wanting it to make like a pyramid. So it's important that they understand that each arrow is half a cup length so that there can be stacking. So I'm gonna adjust my camera so you guys can kind of see what's going on here. So here's my lap. Sorry, I know it's weird. Or here's my desk, which is weird too. Like, if anyone knows why there's a glass space on my desk, fill me in. So here's my stack of 3 cups. Here's my code. The first one says up, over, so that's half a cup length, over and down. The next line says, so then that's my next cup. I'm gonna go up, over, down. And my third line of code is up, because I'm picking it up and then I'm also going higher than the cups that are already there. And then I'm gonna go over 3 times. So 1, 2, 3, and down. It only needs 1 down because it's only going down 1. If it was going onto the table, then they would need a down, down. So there's a cup tower, yeah. And so half cup lengths, so they can stack. Each line of code is a new cup. In my task cards that I created, the blue arrows mean movement, whether it's up, to the side, or whatever, it means movement. If it's a purple arrow, it means flip it. So if in the instructions, it has up, blue, over, blue, and then purple and down, you're gonna flip it and then put it down. So then it's facing up. So that's just an extra piece if they wanna do cups that are flipped up. If for whatever reason they don't have purple or blue crayons or markers or whatever, they can create their own like code how they want it. But so when I was teaching it virtually, they decided to use this kind of curly Q arrow to indicate flipping because they didn't have crayons. So that's an option. They just have to have a key. If they're gonna change it from what everybody else is doing, there needs to be a key, an answer key, so that people who are doing their code know what that flippy arrow means. And you will have kids with super long lines of code, and you can go over there and you can say, I understand as a human being that when you have an up, over, down, and another up, over, down. You probably want 2 cups or 3 cups or whatever. However, as a computer, it just sees that as one long line of code. So if their code is exactly what I had, except all on one line of code, then you would demonstrate with 1 cup saying, oh, this is your code, so I pick it up, I go over, and I put it down. And then I pick it up, and I go over, down. And then I pick it up. As a human, we would know that maybe that's 2 cups. Robots, computers can't think. So that's a big takeaway for this, is that they have to be very specific when they're writing their codes. And that, yeah, that's the main part. They need to be very specific when writing their codes, because robots and computers can't think on their own. Not yet anyway. All right. If you have questions, let me know. I know it's a little, I tried to go through it quickly and it's a little confusing until you do it. So just let me know. I hope that was helpful. And if not, let me know. Maybe I'll stop. Maybe.